This is an animation that shows you how an action potential can get transmitted across a synapse. The bright pulse in the animation represents the action potential. When it reaches the end of the axon, which we call the presynaptic terminal, neurotransmitters are released. Those neurotransmitters travel across the gap between the end of the axon of the neuron that originated the signal and the beginning of the dendrite of the neuron that's receiving the signal. The dendrite of the neuron receiving the signal has receptors in its membrane. We call that the postsynaptic membrane. And when the neurotransmitters interact with those receptors, a new action potential is formed in the dendrite, and that action potential then goes to the cell body of the receiving neuron. Those neurotransmitters can't stay in the postsynaptic membrane, of course, or they would continue to generate action potentials. So they are released by the postsynaptic membrane, and they are taken up so they won't generate any errant action potentials. So that's how an action potential gets across a chemical synapse. Now I want to show you how certain drugs can interfere with this process. Some drugs can inhibit this process by blocking neurotransmitters. The little red bodies in the animation are an example of such a drug. They bind to the receptors in the postsynaptic membrane, and they block the neurotransmitters from interacting with those receptors. As a result, the neurotransmitters cannot generate an action potential, and the action potential gets stopped. Other drugs can actually block the reuptake of neurotransmitter. The orange balls in this part of the animation will keep the neurotransmitters from being taken up, and as a result they'll hang around, causing errant action potentials. Other drugs can enhance neurotransmitter activity. These yellow balls are going to bind to the neurotransmitters, causing them to interact with the receptors in the postsynaptic membrane much more than they normally would. This causes several action potentials to be generated. Now remember, in the nervous system, it's the frequency of action potentials that determines the response. So in the end, this kind of drug really heightens whatever signal is being transmitted across the synaptic cleft.